Okay, we're in section 7. We're going to do the examples, and I'm going to switch to the whiteboard now. All right, let me try that again. Okay, one thing at a time. First, I'll do the first example, certainly. And, reading it, a lot of students read these things and they think that they can just guess at it. None of this should be a guessing game for you. But I do want to communicate to you in Math 119, you were given the absolute value of X. That really dates back to 086, I'm sorry. But the bottom line, 119, you formally define this thing as the absolute value of X would equal X if the X was greater than or equal to 0, and it would be minus X if the X was less than 0. What I know about this one over here, this one says approach 0 from the right side. So what do I know about this? I know that we're to the right of 0, which means we're greater than 0. So this over here is going to be rewritten. Well, the absolute value of X is equal to X if you're to the right of 0. And what's this thing over here? Well, limit X goes 0 from the right. What does this say? Get close to 0 from the right, but never touch it. So this is 1. So this limit is pretty trivial. It's just simply 1 right there. Let's go to page number, not the next problem, not page 2, but we're pretty high up there. Again, I kind of remember what we just did, and I'll write this over here. This is limit as X approaches 0 from the left side, which means we're in negative territory. What's the absolute value of X when you're below 0? It's minus X. Let's keep writing it down. Limit X goes to 0 from the left. You're getting close to 0 from the left, but you're never touching it. So this will reduce to minus 1 because X is not 0. What limit is that? Minus 1. Got that right there. All right, let's keep going. This one over here, the left and right limits do not agree. So this is a clear case of it does not exist. All right, give it to me right over here. Good, number 4. And over here, I'm looking at it. And I'm going to say relatively simple. X goes to 8. Unfortunately, the bottom is 0, so I need to manipulate this thing. So I'm going to factor the bottom, and I'm going to factor the top. And that would be X times X squared minus 64, which would be X minus 8, X plus 8. All right, I'm going to repeat this over and over again. This says get close to 8, but don't touch it. Now, if that's the case, and we're not touching it, this would not be 0, and that would not be 0, so it cancels off. Now I'm left with the limit law. What's that going to be? Well, basically just an evaluation now. It's going to be 8 times 8 plus 8. You're expected to do arithmetic if you can do it. And I think we can handle this. This is 8 times 16, which can be 80 plus 48, which is 128. All right, let's go to the next page. Number 5. And again, this is a problem that, the limit of the bottom is 0, so I can't use a limit law. So I'm going to try to manipulate. Now in Math 120, you learned the Binomial Theorem. So this is easy to expand. This is 1 plus 3x plus 3x squared plus x cubed minus 1 over x. I still have that problematic 0 on the bottom limit. So I'm going to manipulate. And how do I do that? I'm looking at the top. Let me erase this business over here. This is going to be equal to the limit. X goes to 0. And the ones cancel. What do you get? 3x plus 3x squared plus x cubed over x. I'm going to divide through by x now. It's still a limit problem, by the way. We're not done. 3 plus 3x plus x squared. Well, limit law is applied now. I get 3. All right. Go over here, and I see that. Let's do this one over here. Yeah, a little complicated, but the bottom line is the limit of the bottom is actually 0, so I have to manipulate. And I'm hoping for cancellation. 3x minus 3. And what do you get on top? 3x minus 3, 3x plus 3. It's a fairly simple factorization problem. The kind of factoring that you might have done in Math 119. What do I know about this? You're approaching 1, but you're never going to touch it. So the bottom is never going to be 0. And this is never going to be 0. Right? Those factors cancel off. What you left off with a pretty simple limit law problem. 3 to the first power, which is 3, plus 3, which is 6. That's done. All right, number 7 is a little interesting. I want to tell you why it's interesting. This says approach 0 from the right side. I couldn't have just approached zero. I'll tell you why. Those limits on the bottom wouldn't exist. I couldn't even say they're zero, but they don't exist in the bottom. And why is that? These even roots here, we're going to approach the radicand with your positive numbers. All right. And we're okay with that. So I'm going to, maybe this one looks like it might be a lot of manipulation, but you know what? Let's just give it a try. So limit x goes to 0 from the right side. This would be 1 over root x minus, well, this is going to be root x times root x plus 1 over 1. I know it's a lot of work, by the way. And it's frustrating sometimes if work doesn't lead to an answer. It happens all the time. I'm going to common denominator. What would that be? Root x plus 1. That's common denominator, by the way. And what do you get there? You get root x plus 1 minus 1. I'm going to multiply the top and the bottom by the conjugate. And that's going to be root x plus 1 plus 1, root x plus 1 plus 1. It's frustrating. I know that. Somebody says, is this ever going to end? It's going to end when it ends. I also soon say, do I need to show work? Yeah, you need to show work. So what do you get on top? You get x plus 1 minus 1 with just x. What do you get on bottom? It's a nightmare. You get root x plus 1. And then you get this. You get root x plus 1 plus 1. Well, I'm still in that, I would say infinite loop. Let's see if we can get that. Now, what do I get? And again, these roots become very easy because there's always to the right of 0. So this would be root x. On bottom, what do you get? Root x plus 1. And you get root x plus 1 plus 1 here. I can do the limit now. The limit of the top is 0. Whoops, sorry about that. The limit of the top is 0. And what's the limit of the bottom? Well, it's root 1 times root 1 plus 1, which is going to be 0 over 2, which we know to be 0. All right, let's go back. And I know it's a lot of work. And we see it. And that's not bad. Let's go to the next one, number 8. Number 8 looks like a nightmare to me. My understanding of these nightmares, for me anyway, I don't like the cotangent, I don't like the cosecant. So I'm going to rewrite it into a form that I prefer. I actually prefer sines and cosines, but again, your mileage may vary. You may say, I don't prefer sines and cosines. I prefer something else. But the cotangent is actually cosine of x over the sine of x. And the cosecant on the bottom is just sine x. Well, what do I know about this thing? If I looked at it, I probably could do this now without much problem. So for example, if x goes to pi over 2, the sine would go to 1. That's not bad. And the cosine would go to 0. So what'd you get? You would get 0 on the top, 1 on the bottom, which is not a problem. So it's 0. Okay, let's keep going. This one's a little crazy looking, right? This says the limit as x approaches 2 from the left. I'll write this over here. And what I need to do is I need to focus on, there are 2 different functions. Question, which one is it? Well, this says 2 from the left. This is 2 from the left, so it'd be 2x. Yep, you need to write that down. Limit laws, this gives me 4. Done. The next question, this says the limit as we approach 2 from the right side. It's not a memorization, it's a reading skill. Which one of these functions will I approach from the right side? That would be x squared. What's that limit going to be? 4. All right, did we get that one? We got it. All right, and again, work is being done for you. Let's put down the next question. C is what's the limit as approach 2? Well, if you don't remember, I have to look at both the left and the right. And are they in agreement? They're in agreement. They're both 4. So what's the limit over here? It'll be 4. All right, what's f of 2? I don't know. I got to go back and look at it. What's f of 2? Well, f of 2 is going to be this line over here. So let's go back to that. F of 2 is going to be 2 squared. And what's 2 squared? It's 4. Boy, a lot of 4s all over the place. All right, let's go to number 10 and see if we can do it. This says approach the number -1. Well, I got trouble in the bottom, limit of the bottom 0. So I have to rewrite this. X goes to -1. The top factors. x plus 1, x minus 1 over x plus 1. Now, what do I know about this thing? It never touches minus 1, so the bottom is never 0. So these cancel off. And what he left off with a really simple limit law problem, minus 1, which is minus 2. All right, a little more complicated, and I got to figure it out. And so this one says approach 0. I got troubles. I'll tell you what the troubles are going to be. So limit x goes to 0. And I'm going to get the square root of x squared times, I factor out an x squared, right? So it's going to be x plus 1. That's not such a bad thing. And on top, I'm going to factor an x out. And what do you get over there? You get x plus 4. Someone says, why'd you do that? You don't have to. I'm just saying that I need to do it. Right? I need to rewrite this. And what do I know about this? And I'll write this down for you. So the root of x squared is actually identical to the absolute value of x. And and again, you learn about that in Math 119. I know it's probably, somebody says, well, I didn't really learn that. Well, it's covered in Math 119. It's an important concept. That's going to be equal to x if the x is greater than or equal to 0, and it's minus x if the x is less than 0. So now I'm starting to see I immediately have problems, and I'll write them down for you. So I'll write this down. Limit as x approaches 0 from the right. Well, the top is going to be x plus 4. This is called work. We need to work. Now, if you're to the right of 0, the square root of x squared is just going to be x. And they get root of x plus 1. Well, this is a really nice, easy limit to do. And why is that? Well, x is not touching 0. These things cancel off. And I get a really simple limit. Top will be 4, and the bottom would be 1. So I get 4. Now let's do the other limit, the limit. Yeah, you have to do both. And what do you get over there? Well, you get x plus 4. But the square root of x squared when you're below 0 is actually minus x. And what do you get there? Well, x is not 0, so these things cancel off. And what do you get over there? You would get x plus 4 on top, and you would get minus the root of x plus 1 on the bottom. Can I do that by limit law? Sure can. The limit at top is 4. The limit at the bottom, plugging in 0, you get the root of 1, but it's the opposite of it. So minus 1. So what's that going to be? Minus 4. Now, what do I know about the limit they've asked about? This limit over here is DNE. And why is that? The left and right limits we have shown are different. So DNE is a appropriate answer. Let's go to the next question. And again, they put a lot of work over there. They also put a graph down there for you. And the graph should be very convincing that the left and right limits of that problem are different. On the right side, let me blow this up for you. It goes to 4. On the left side, it goes to minus 4. As we've indicated, what's being graphed out? This thing's being graphed out. Okay, so someone's going to say, oh, this is awful tricky for me. I don't know if I'll be able to remember that. This is key. You got to remember that. And you got to remember the definition of absolute value. Let's go to the next question over here. And I'm looking at it, and I notice immediately that I can't do this by limit law, so I have to manipulate limit. X goes to 0. Hoping it's an easy problem to do. You get x times e to the 1 minus 2x. Factor the bottom. That would be x plus 1. What happens here? X is not 0. So these things cancel off to 1. If it was 0, they wouldn't cancel, by the way. What do you get over here? Well, it looks pretty easy. When you go towards 0, the top would be e. And if you go to 0 on the bottom, it would be 1. So what's the limit of that thing over there? Just a. Okay, that's done. The next question. Make sure I did the right thing. Yes, 12. Let's go 13. Okay, 13 looks tough. That good. Someone says this keeps popping up. This absolute value keeps popping up. Yeah, they're seeing if you understand. All right, so I got to write this down. Two different things. Let's write this over here. Limit as x approaches 0 from the right. Well, what do you get over here? You would get 2 over x minus 2 over. If you're to the right of 0, the absolute value of x is just x. Now, what do you get over there? Oh, I just combine them together. What do you get? It's pretty simple. I mean, x is not 0, so I can combine them together. You would get 0 there. What's that limit? 0. That was easy. Let's do the next one. Limit as x approaches 0 from the left side. And what do you get? 2 over x. Well, let's say it's the absolute value of x. That would be minus x, right? So what do you give here? 2 over x now. Limit x goes to 0 from the right. That would be 4 over x. All right, a little difficult. I realize that. So what are you going to do now? And I'll talk about it. You're getting close, and you did this in Math 119. If you're getting close to 0 from the right side, they're definitely positive numbers. And 4 divided by a positive number is definitely a positive number. Here's the deal, though. The bottom gets incredibly small, so this will be blow up. It's called asymptotic behavior. By the way, this is the answer we want you to list for this one, and this is the answer we want to list over here. A lot of books will say this D and E. It's true. It's not a finite number. We'd like to know if it's going to plus or minus infinity. So what's my conclusion over here? Well, they're not in agreement. So this is D and E. They go through both of the limits. Wait a second. I'm sorry. I made a mistake here. I got to go back and correct it. And I want to point out what I did over here. You notice there's minus sign over here to the left. I want to do over here. I copied the wrong thing down. So I have to erase this. And it's going to happen when you're doing homework. And we want to encourage you when you're doing homework, fess up to it. Say, I got a wrong answer. I got to correct it. And I'm going to correct it now. We'll talk to it again. What are you doing? Well, I know the top number is 4. That's always going to be 4. And the bottom number, I know it's a negative number. Why is that? It's to the left of 0. So I know my answer is negative. But I got to, communicate to you again. It's something you did in Math 119. You're dividing by an incredibly small number, and that's going to blow up. So minus infinity. All right. They don't agree. It's DNA, and these answers are listed over here for you. All right. This one over here, again, we're not trying to trick you, but I want to claim over here is it possible? Right. A lot of students are going to say, oh, it's just 0, call it a day. It would be a wrong answer. Let's go through that. All right. So what I want to do is I want to emphasize to you, maybe you should do a little bit of thinking over here. So what are you doing? The number 4, and you're to the right side of it, which means you're from a number bigger than 4. I want to point this out to you. 16 minus a number bigger than 4 squared. Well, that would be 16 minus a number bigger than 16. This thing would be a negative number in here. And I hope you realize that I can't do that. I can't take the square of a negative number. So D and E. I want to do it one other way. I'll put this down for you. Y equals, this is a visual approach, 16 minus x squared. You might want to square both sides. But before I do that, I want to point out this is a principal root. So y is greater or equal to 0. Y squared is 16 minus x squared. X squared plus y squared is equal to 16. This is a circle centered at the origin, radius of 4. So this would be minus 4. That would be 4. But it's not the picture of the original problem. And why is that? We have to erase anything that's negative in the problem. So let's put this picture down for you. And a picture would look like this over here. This would be minus 4. And this would be 4. So let me just erase that nonsense, or not nonsense, but stuff that, basically you did in Math 100. So that's the graph of that. All right, I don't need to put this down either. So the question is, can you approach 4 from the right side? And the function doesn't exist there. So this is the right of 4, but the function isn't over here, so you couldn't approach it. So it's a D and A. All right, so let's keep going. Whoops, sorry about that. Let's keep going. Let me put that over there. And let's do this one. Well, again, I just did it, right? So I guess I could draw the picture again, but now it's from the left side. So what are you going to get? 0. Let me go through that with you. Left side of 4 is going to go towards a 0. All right. We did okay. All right, let's keep going. By the way, the answer is there. 16, last problem. It says you're given something. My fear about if I'm given something, they're going to want something, or they want this guy's limit. Well, I got to get it to look like this. And right now it doesn't look anything like that. Let's write this down. Limit x goes to 0. And 1 minus cosine squared is going to be sine squared over x squared. You may remember your teachers in Math 120 said that sine squared is kind of confusing, so you should really explicitly state what it means. And what does it mean? It means sine x times sine x. What's on the bottom? Explicitly, it means x times x. Well, I think I see what they want me to do. Both of those limits are 1. For example, this goes to 1 and this goes to 1. And what's 1 times 1? It's 1. All right, that work is down there for you with the answer. All right, let's talk about the interface you're at now. So the interface is going to be, you're here. All right, so what do you do here? Make sure you study. What are you studying? What we present to you in class. Right now, you're studying the examples and you're studying the lectures. After you do that, you're going to go here and you're going to see if you can do these problems over here. What I've noticed from some students, though, what they do is they say, I don't really think I need to study. I'll just wing it. I'll go to the exam and that's what I'm going to give it a try. It doesn't work. You got to study. If education were of that nature, which unfortunately is for a lot of people, where there's very little effort put forward to the study department, when they get to the exams, they're usually befuddled. They'll even ask questions that are kind of ridiculous, like, what does this mean? What does that mean? What does it communicate mean? They're doing little to no work. That's probably something you don't want to be advertising to the world, by the way. So if someone asks you to do a hard job, say, yeah, I'm studying all the time. I have no time for anything else. Here's the deal, though. If you don't do that study of the prior material, the lecture notes, what I do in examples, don't bother with the homework. You got to study before you do homework. Once you study, the homework should go incredibly quickly. And I hope it does. Thank you.